Well, hi everyone, this is Bob the Science Guy. Today I'm going to continue talking about multiplying vectors using a different type of technique called a cross product. Now, as you recall, the dot product multiplied two vectors with a like vector times a like vector. And we primarily used it to find the angle between those two vectors. Now, the cross product finds something that's a little bit different. It's called the normal angle. The normal angle, if you were to define a plane by your two vectors, for this purpose I'm going to just use the x-axis and the y-axis as being vectors. The cross product will find a vector that is 90 degrees to that plane. And when we study electromagnetic energy, this will become important. You look at waveforms versus magnetic fields, etc. But for right now, it's more of an academic exercise just to understand how they're formed. Okay, so let's take two vectors. We'll take vector A and we'll take vector B. And we'll describe vector A as follows. 5i plus 3j minus 2k. And these are, of course, unit vectors. Vector B, on the other hand, will be negative 3i plus 2j plus 4k. Okay. Now, what we need to do is we need to put this into what's called a matrix. So we'll have I, j, and k. And underneath it, we'll put the magnitude values for each of the vectors. So 5, 3, minus 2, minus 3, 2, and 4. Okay, and this is vector A and this is vector B, just to kind of keep ourselves oriented a little bit. If we look at vector I, what we do is we ignore these values up here, we ignore these values over here, and when we're looking at vector I, we simply cover up the values from vector I, and we're left with a 2 by 2 matrix. So if we come over here, we'll have 3 and 2, negative 2 and 4, and that will be our I value. Then we cover up j, and we get 5, negative 3, negative 2, and 4, and that will be our j vector. And then finally we cover up k, and we get 5 and 3 and negative 3 and 2. Okay, now what we do is we cross multiply. That's why this is called the cross product. So what we do is we take 3 times 4 minus negative 2 times 2, and that's going to give us our I value. And then we're going to take 5 times 4 minus negative 2 times negative 3, and that will give us our j value. And then of course finally we've got 5 times 2 minus 3 times negative 3, and that will give us our k value. Okay? In order for this to work out right, you would think that you would just add these two and then add this. That's not the way it works. You have to subtract here and add here. And this will give us our answer. So this is 12 minus 4, I, minus 20 minus 6, j, plus 10 minus 9, k. So what do we have here? We've got 16i minus 14j plus 19k. And this is our final vector, which is 90 degrees to the first two vectors. Now, the next question that we have, is this a positive or a negative? Well, that's rather easy to find out. All right, so let's figure out, is our resulting vector going to be in a positive direction, or is it going to be in a negative direction? We have to use something called the right-hand rule for that, and here's the way that you do it. Now, let's do vector A cross vector B. Okay? And that's going to come up with a vector C, but is vector C going to be positive or negative? So what we do is we take our right hand and we put the index finger on the first vector. So in this case, I'm going to put my index finger on vector A. Then I'm going to take my middle finger and put it out in the direction of vector B. Now notice that this is correct for vector B. Now for vector B cross vector A, okay, we would take the index finger, I would put it on vector B, and then bring my middle finger in the direction of vector A. Now, then I stick my thumb straight up. Now notice that this is coming out of the page. So vector C will be positive. However, if I went vector A times vector B and went like so, my thumb, when I stick it straight out, is going down. So vector C will be negative. I know the book talks about corkscrews and things like that, but use your fingers and just use your thumb 90 degrees to your palm to give you the direction of the resulting vector. Another way that you can do this is that vector A cross product vector B equals vector A vector B sine angle theta between them. And again, what we're doing is we're using magnitudes. So if vector A is 10 and vector B is 8, we've got 10 times 8 times sine angle theta between them. I'm not going to address anything more with cross vectors right now. This equation right here would be helpful to you in understanding the idea behind the matrix here. So when you're doing your vector, remember, you cover up the value that you're looking for and make a matrix out of the other four values and cross multiply them. You subtract, you go upper left to lower right, subtract from that upper right times lower left. And make sure that you put this negative sign in between the first two terms, the I term and the J term. I should probably go like that. And then a positive sign between J and K. So that's the cross product. And again, I don't have a lot of use for it right now, but that's basically what it is and how you find it. So this is Bob the Science Guy. Next videos, we'll start talking about kinematics.